What's going on, guys? Let's look at this problem right here. Here this question is asking, in a balanced three-phase Y delta system, the source has an ABC phase sequence and VAN is equal to 120, the angle is 40 degree VRMS. The line and the load impedances are 0.5, the line impedance is 0.5 plus J 0.4 ohm and the load impedance is 24 plus J 18 ohm respectively. Find the delta currents in the load. Now let's go ahead and draw the circuit. Here delta, okay, and this one connected to the first voltage source. Actually it already connected. Let's get rid of this one. This one connected to the, here we will have impedance. Connected right here, and resistance and impedance. Connected right here. Okay, so plus. Here the voltage is 120, the angle is 40 degree, and this is 0.5. The line voltage, resistance is 0.5. This is J 0.4, and this is load current ILA, and then here the current is IAB, and this current is ICA, and this current is IBC, and this one is C, this is A, this is B, and here this is A, this is B, and this one is C. Now the first thing is we are going to convert this one into convert this one into Y circuit. Let's go ahead and convert. This one is already, this side is already in Y, so we don't have to worry about that. How do I know this is Y delta? It's mentioned in the question, Y delta. So one side is Y, the source side is Y, and this side is delta. Now we are going to convert both sides into Y. This is already Y, so I keep this one as it is. We don't have to change the voltage because this is already like this. I am keeping the same system. Now if I convert the resistance into Y, I have to divide this one by 3. Here the line resistance is, impedance is 0.5 plus J 0.4, that's what here, and then we have load impedance, that is 24 J18. Now if we divide 24 J18 by 3, that is 8 J6, 8J6, okay, 8J6 This is 120 40 degree, and here we have 0.5 J 0.4. .5 J 0.4, and this is 8 J 6, and this one is A, this one is B, and C right here, plus plus plus. Now let's make a simple circuit. This is 0.5 J 0.4, and this is 8 J 6. 120 angle is 40 degree voltage. Now next thing that we are going to calculate the line current. V is equal to IZ, V is equal to IZ, I is equal to V over Z. V is 120 40 degree divided by this impedance. Here we have 0.5 0.4 0.5 0.4 impedance, and the next one is 8 6 plus 8 6, and if you calculate the current, that's going to give you 18.3, angle is 3.02 degree ampere. Now let's go ahead and put it in a triangle. Triangle. And the current this side, going this side and this side. This side is IAB, and this side is negative ICA, and this is IBC, IBC, ICA, 30 degree. Okay, now we found out ILA. ILA is equal to 18.3, angle is 3.02 degree. This is 30 degree. Now let's go ahead and find out ICA. ICA is 18.3 divided by root 3, because if we go to delta we have to divide by root 3, and the angle difference is 120. 33.0 C 33.0 degree, because 33 come from here. Let's put IAB first, because then only you can know how did we get 33. If we take a IAB from the triangle, let's put the direction of the triangle. This is A, this one is B, and this one is C. So IAB is here, and from the line current, this is the middle one is the line current. Line current we found out to be 3.02, and from this one we have 30 degree. That's how we get 18.3 divided by root 3, because we are going from y to delta, so we have to divide by root 3, and 3.02 plus 30 degree. Okay, that is IAB. Now ICA, we have to add 120 to that, 120 degree ampere, and after that IBC is going to be 18.3 divided by root 3, square root of 33.02 degree minus 120 degree, and that's it. That's how you do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electromechanics, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.